Hello everyone. In last video we have discussed on distance time graph. In this video we will discuss on velocity time graph. So what is velocity time graph? The variation in the velocity with time for an object moving in a straight line. There is one object, it is moving in a straight line, and when object is moving, how the velocity of that object is varying, or the variation of that velocity we are plotting against the time. So that plot or that graph is nothing but velocity time graph. For an example, we have taken this velocity time graph. What it indicates? This velocity time graph for a car moving with a uniform velocity of 40 km per hour. So this car in a journey when time 0, still the velocity was 40. After 1 hour also it was 40, 2 hour also 40, 3 hour also 40, 4 hour also 40. Throughout the journey, the velocity is maintained. The velocity is uniform and it is 40 km per hour. So this line indicates the velocity time graph. This x-axis is the time axis and this y-axis we have taken velocity. So time axis is the or x-axis, there is time axis I will say, and the y-axis here we have taken the velocity. Now the object moves at a uniform velocity. The height of its velocity time graph will not change with time. Mainly regarding with the uniform speed we have discussed. Now when we are talking about uniform velocity here, as we know that speed and velocity are different, they have different understanding. Speed is the scalar quantity and velocity is vector quantity. In terms of a velocity, we need to mention about magnitude and direction. In terms of a scalar quantity, only the magnitude has the importance. Now, for understanding, suppose I have created some shaded area and some uh, lines I have drawn here. So actually, this line indicates the velocity time graph that we know. This line indicates the velocity time graph, and this is the time axis. Now, if you look the height between the velocity time graph or distance between the velocity time graph and the time axis throughout the journey, when time is 0, so this height is how much? 40. After 1 hour, it is 40, 2 hour, it is 40, 3 hour, it is 40, 4 hour, it is 40. So throughout the journey, this height or distance, I will say distance between the velocity time graph and the time axis, it remains constant. So here this height in this velocity time graph, it is not changing with respect to time. With respect to time, this height is constant. Now the basic formula we know that velocity is equal to displacement divided by time, right? So from this formula, if I want to calculate the displacement, how I can calculate velocity into time? Obvious, velocity into time is equal to displacement. So product of the velocity and time, it gives the displacement for an object moving with a uniform velocity. So here, if I want to find out the displacement for the car traveled through this journey for with the uniform velocity, I need to take a product of velocity and time. So it will give me the displacement. Now the area enclosed by the velocity time graph and the time axis is equal to the magnitude of displacement. So in earlier videos regarding with the distance time graph and velocity time graph, after discussion, we have drawn three conclusions. First conclusion was the slope of the line in distance time graph gives magnitude of velocity. Second, in velocity time graph, the slope of the line it gives magnitude of acceleration. And third is in the velocity time graph, the area under the line, or area under the curve, it gives magnitude of the displacement. So keeping that in mind, here also for this velocity time graph here, the area below this graph, whatever the area below this graph, between this velocity time graph and the time axis, actually that area will give us the magnitude of the displacement during that travel of the object. Now suppose I want to calculate the distance moved by the car in time t1 and t2, in between t1 and t2. Here the time is t1 and here is the time is t2. C is corresponding to t1 and t2 is corresponding to d, or d is corresponding to t2. So in between this means in the time t2 minus t1, how much distance the car has traveled if I want to know that, how to calculate it? So how to calculate the distance? Simply from this point T1 or this point C, I will draw a line, the line perpendicular to this time axis, and from T2 also or from point D also I will draw a line perpendicular to this time axis. So that line will intersect to this velocity time graph at a point A, which is corresponding to the point T1, and at point B, which is corresponding to the time T2. So now we have the rectangular area A, B, C, D. And actually, this rectangular area, this rectangular area is below the velocity time graph and in between the velocity time graph and the time axis. And we want to know that how much distance traveled by that car in time T2 minus T1, or when the car is moving from, I will say, from point A to point B, or during the journey from A to B, how much distance covered, that we want to know. So that distance or that displacement is nothing but the area under this line AB. So that area, if I want to know, obviously that area means rectangle area ABCD, that area I need to calculate. How I can calculate the area of this rectangle? Obviously, S is equal to AC. AC is the height and CD, right? AC into CD I want to calculate. So AC is nothing but the height with which that car is going with uniform velocity, and CD is the T2 minus T1, the corresponding time in hours. Now if I calculate, so S will come, it is 40 into T2 minus T1 kilometers, right? So this S is nothing but the magnitude of the displacement for the travel, for the travel of that car in time T2 minus T1, right? So this particular area under this curve or under this velocity time graph for the time T2 minus T1, for the time T2 minus T1, so that S will be the area of the rectangle of the ABCD or ABDC, and that is actually nothing but the magnitude of the displacement. So like this is a small introduction to this velocity time graph and how from the velocity time graph we can calculate the magnitude of displacement. Thank you.